Okay, this is about sensor characteristic. Yeah, the accuracy, the resolution, the sensitivity, the precision and repeatability, linearity, and also about drift. So, displacement sensor is measure a linear displacement. In example, a change in linear position be the change in linear displacement of a sensor as a result of a change in the thickness of sheet metal emerging from rollers. So we also have measure an angular displacement, detect motion, detect the presence of some object. Alright. So for displacement measurement, we measure size, shape, and position utilize displacement sensor. For example, a diameter of part under stress, movement, a microphone diagram of two quality liquid movement through the heart. So the primary transducer type, we have resistive sensor, inductive sensor, capacitive and piezoelectric sensor. For the secondary transducer, we have Wheatstone bridge and also amplifiers. So this is displacement sensing. So LVDT, linear variable differential transformer, it's convert a position or linear displacement from null position into a proportional electrical signal containing phase, which is direction, and amplitude, which is distance information. So inductance based electromechanical sensor, it is infinite resolution limited by external electronics only. Then its limited frequency bandwidth is about 20 to 50 Hz, typical for DC LVDT, 500 Hz for AC LVDT. So the operation is no contact between the moving core and coil structure. The advantages is no friction, no very long operating lifetime. And it is also accuracy limited, mostly by linearity, 0.1% to 1% typically. So model with slope from mm's to 1 mm is available. This one also displacement sensing, which is a linear potentiometer, and the description is as shown. What about that one? Okay, temperature sensor operation actually. It is a resistant temperature detector RTDs, alright? Okay. Normally, typical use is from platinum, nickel, or copper metal. So it is a positive temperature coefficient. So the other one is thermistor, thermally sensitive resistor formed from semiconductor materials. It is not metal. So often composite of a ceramic and metallic oxide. Alright. So it's typically have negative temperature coefficient, right? For temperature sensor option, the famous one is thermocouple. So it is based on the Seebeck effect, dissimilar metal at different temperature. So metal A and metal B, so have two junction here. Okay, so this one is still reference connecting leads, and we can have V out here. Alright, so table at the bottom show the difference between thermocouple RTD and juga IC. Alright, so we compare the three things here from view of accuracy, ruggedness, temperature, drift, linearity, response, and also cost. Okay. Alright, ini ialah berkenaan dengan fiber optic temperature sensor. So, nothing important here, but yeah, you all can read here. And also about motion sensor, here we can see this transducer measure the following variable: displacement, velocity, acceleration, force, and also stress. So such measurement are used in mechanical equipment like servo system, robots, and also electrical drive system. Other than that, motion sensor include the following type of devices, which is potentiometer, resolver, optical encoder, variable inductor sensor, and so on. Okay, this is about resolver, strain sensing, strain gauge. Okay, this one strain sensing again. Okay, okay, this is the last one about strain gauge also. Yeah, strain gauge. Okay, the formula is very simple as long as you know how the diagram, where the value of R1, R4, where is the place for R1, R2, R3, and R4, where is the V input or V supply, then simply direct question, put the value here, and you can get the value of output voltage, right? Output is at the junction B to D, okay, ball to donkey. So here V output, all right. So that's all right. That's all for chapter 4 on topic transducer. So this is the part 3, which is the last part of the chapter 4 transducer. So that's all for me, and yeah, see you next video, in the next video. Thank you. Assalamualaikum.